Okay, so we're going to continue with a little bit of similar triangles, but we're going to talk about similar right triangles and what the geometric mean today. So there is a right triangle similarity theorem that pretty much says if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are each similar to the original triangle and to each other. So that means that triangle CBD is similar to triangle ABC, and triangle ACD would be similar to ABC. And then also CBD would be similar to ACD. So that is the right triangle similarity theorem. Okay, so let's see if we can try this real life example. So a roof has a cross section that is a right triangle. The diagram shows the approximate dimensions of this cross section. Find the height H of the roof. Okay, so if you think of this little triangle, we know this is 3.1 and we know the height is H. And we know it's going to be similar to triangle YZW. I should probably write this one out. So this is YWX. I'm just trying to put them all in the same layout. So this would have been, this is H and YZ is 5.5, right? And then we have the other triangle, which is the whole thing, which we know is XYZ. So what do we know about that? We know this is 6.3. We know ZY is 5.5, and then we know that XY is 3.1. So this is using the right triangle similarity theorem, that pretty much this triangle is similar to this triangle, which is similar to the whole thing. So that's going to help us find H. So if you guys can set up a proportion, let's do that to find our height. So we know there's many possible ways to do this. I'm going to use H over 3.1 equals 5.5 over 6.3. Let's solve it. So you should get H is approximately 2.7 meters. Okay, so that's using the right triangle similarity theorem. Okay, so let's talk about what is a geometric mean. I don't know if you guys have heard this before, but a geometric mean of two positive numbers, A and B, is the positive number x that satisfies this proportion. So x squared is equal to a times b, and x is equivalent to the square root of ab. So if I asked you to find the geometric mean of 24 and 48, it would just be x squared equals whatever 24 times 48 is. If you set it up in a proportion, it would be 24 over x equals x over 48. And we should be able to simplify this. So x equals 1,152, I believe, is divisible by 576. Should be a perfect square root, yeah. So 576 times 2, which is 24 radical 2. So that means the geometric mean of 24 and 48 is 24 radical 2. Okay? Alright, so let's go over, there's actually two more theorems with right triangles, and the first one is called the geometric mean altitude theorem. And it says in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. So we're talking about AD and dB. And the length of the altitude is the geometric mean. So CD is the geometric mean of the lengths of the two segments of the hypotenuse. So what does that mean? That means that CD squared is equal to AD times DB. Okay? And we'll use this theorem in a second. The next one, right, so just remember, this is the altitude theorem. This one is the geometric mean leg theorem. And it says in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. And the length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse. Okay, so we're still using our altitude that divides it up, but now we're going to talk about our legs. So we're going to focus on CB and AC, okay? But it's still going to divide up, this altitude is still going to divide up our hypotenuse. But the leg theorem is saying that CB squared is equal to DB times AB. Okay. Yeah. So I don't know if you, I know I didn't read this out loud to you, but I just want to make sure you understand that the length of each leg, so CB, is the geometric mean of the lengths of the hypotenuse. So it's the whole hypotenuse. And the segment of the hypotenuse that's adjacent to the leg. So that's why we're going to multiply, we're multiplying AB by DB, because DB is adjacent to CB. Sorry, I dropped my cap. All right. Now, the next one is side AC. So AC squared is going to equal, you probably can figure that out, is, so the segment adjacent to it would be AD, and we would multiply by the whole hypotenuse AB. Okay? So that's the difference between Theorem 9.7 and Theorem 9.8. So let's see if we can use those theorems to answer these questions. So letter A saying find the value of X. So for this one, it looks like we're going to use the geometric mean altitude theorem, right? Because it's giving you X as your altitude. You have to find the geometric mean. So according to the theorem, X squared is equal to 18, right? 6 times 3. And the square root of 18 we can break up into 3 radical 2. Okay. This one, it looks to be like the leg theorem. Geometric mean leg theorem, I should really say. And how do we find that? So we know that y squared is going to equal to 2, right? So y is adjacent to 2, and the whole hypotenuse is 7, so y squared should equal 14, and the square root of 14 cannot be simplified. Okay, awesome. Do you guys want to do the last example without me? And then maybe compare answers with someone at your table, and then go back to today's agenda and start your classwork. Bye, guys.